Hi everyone. This is the second part of complementary angle, concept of complementary angle, in which I am going to discuss about some interesting question which is based on the concept of complementary angle, which is a part of trigonometry. This chapter is actually deleted from the according to the CBSE point of view, but this is a very important chapter for the competitive examination. So how we have to proceed to this? So we have already discussed the three formulas of the complementary angle in the previous video, which is the sine of theta is equal to cos of 90 minus theta, and again we have the sec of theta which is equal to cosec of 90 minus theta, and the another which is the tan theta is equal to cot of 90 minus theta. This is the three formula which we have already discussed. A cot of 90 minus of theta. Using this identity and some identities which you have already studied in the trigonometric identities, which is the sine square plus cos square is equal to 1, and the 1 plus cot square is equal to cosec square, 1 plus tan square is equal to sec square theta. So this formula which you have already learned in the previous chapter. So how we will solve this one question? The first question we have the sine square of 65 plus the sine square of 25. So how will you solve? So for this, as I said you have to just make the using the formulas. So this is can be written as sine square of 65, and this one sine square of 25 can be written as the cos square of 25, the cos square of 65. Using this identity you could write this one, this is the cos square of 65. So it is what? It is the sine square of theta and plus cos square of theta, and you cos square sine square of theta plus cos square theta is equal to 1. So the answer is going to the 1. So 1 is going to be the answer of this question. So this one is a very easy question, and just try the another question, which is the sec square of 36 plus cot square of 54. So how will you solve this one? So when you are going to solve this one, you have to see that this is sec square of 36, and this can be written as the tan square of 36 using these identities. So this can be written as tan square of 36. But even though you will not able to solve, then you have to use the identity. Let's suppose, as you know identity, the sec square of theta, which is the 1 plus tan square of theta is equal to sec square of theta. Using this identity, you could write here the 1 plus tan square of 36 minus tan square of 36, and this one will be cancelled out. The answer will again 1. So this is the answer of this question remains 1. Answer of this also remains the 1. So we solve the two question. Now just try the another question. These are the very easy question if you already solve the chapter named as the trigonometric identities, because this chapter is based on this trigonometric identity. Now solving this one, which is a very interesting question, and a student may confuse to solve this one, which is the tan of 1 degree, and then into the tan of 2 degree, then tan of 3 degree up to the tan of 89 degree is equal to 1. This is what we have to prove. But how will you proceed now this one? So just this means it will go up to the tan 189 degree. So how will you solve this one? So for this I would like to write like this: the tan of 1 into the tan of 89, then tan of 2 into the tan of 88, and then tan of 3, and then into the tan of 87. Like this you could write, and up to many, because just we had multiply, just we make it closer, and we also make it closer because all the values are given here. So just we arrange in the sequential order so that we could prove this one easily. So you may also know that the tan of 1 which is the cot of 1, using the identity this one can be write as cot of 1, and tan 1 cot 1 will be cancel out and answer is 1 here. And then when you solve this one, 1 also here. So when you multiply 1 multiple time, then answer you will get the 1. And this is what you have to prove in this manner, that first you have to arrange, then cancel out, then you will get the 1. When you cancel out these two, you will also again get 1. When you cancel out this one, you get the again. So you will get a consecutive pair, and then you be able to cancel out. And when you multiply 1 multiple time, the answer will remain 1, because you are not adding, so you will get the any other answer. You are just multiplying 1. So this is why you will get this answer. And now a very interesting question which come to you. How will you solve this one? Which is the 2 sine square of 63 plus 2 sine square of 27 plus of 1, and then it is the 3 cos square of 17 plus 3 cos a square of 73, then minus 2. How will you solve this one? This seems to be very interesting, but this also is somewhere going to a difficult one, because you have to prove this is all equal to this one. So how will you solve? So first you have to see that we have the squares in the function, then you have to use the identity. If you are able to see that a squares have in the function means the sine, cos, tan, cot and sec, like this. So when you get the squares, then you have to use the identity. So write this one like this, the 2 sine square which we have, the 2 sine square 27, this one which can be written as 2 cos square of 63, like this you could write. So write here the 2 sine square of 63 plus 2 cos square of 63 plus of 1. And now this one is the 3 cos square of 17, and this one can be written as the 3 sine square of 17 minus of 2. Now you get to this one. Now how will you solve? So if you will take the common 2, then you will be able to use identity, which is the sine square theta plus cos square theta is equal to 1. So taking here the common, from this take the common, then you 2 common, then you will get here the sine square of 36 plus cos square of 63, then 1, and then you will take here the common 3, then you will get the cos square of 17, then sine square of 17, then here you minus 2. And this is what? This is actually 1 using the identity, and this is also 1. So 2 multiplies the 1, remains the 1, and plus 1, it's become the 3. And now here the 3 multiplies the 1 3, and then when the 3 minus 2 becomes the 1. So it becomes the 3 by 1, which is actually the 3, and this is what we have to prove. And I think you got how we have to solve this question, and thank you for today.